Thanks for stopping by. We're going to be introduced to a new data type that Roblox has provided for us called Vector3. So pretty much a Vector3 is a value that allows us to manipulate specific properties inside of our 3D world, usually with things that have to do with positioning of parts inside of our world. So it's definitely a very powerful data type, which is why we're going to be introduced to how to use Vector3s inside of our 3D world through scripting. And so I basically whipped up like a little example here with this part. So basically what should happen is something magical when I click this part. What happens is when I click it, then bro, this part is just flying by. It's just like sliding all the way out to somewhere that's not close to me because this part does not love me. But yeah, I basically just constantly changed the value of one of its positional values to go in this direction forever and ever after I clicked on it. So this is with the use of Vector3, and I'm going to be showing you how to do this. But before we start implementing Vector3s, I want you to really understand how this all works, and I'm going to do that by showing you an example. Alright, let's think about this for a minute. So I'm in a game of Minecraft, and I know it's kind of weird, but trust me, it'll make sense. Minecraft is a 3D game, and it has a 3D world that has 3 directional values that correlate to the location of where the player is inside of the game, called the X, Y, and Z coordinates. And if you want to see these coordinates, you have to press F3 on your keyboard like this. That shows a bunch of statistics of the world that you're currently playing, but we're mostly interested in the X, Y, and Z values on the left side. So as you can see, our X, Y, and Z value, our X being -16, our Y being 63, and then our Z being 239. If we move around inside of the workspace, these values are changing accordingly to where we are inside of the world. So if I move in this direction, then it's increasing the X value every time we move in this direction. So this is called the X direction. And if we move backwards, then we're decreasing our number in the X axis or coordinate. And now let's say we go this way. This is increasing our Z value every time we move forward inside of this direction. But if we move backwards, then it's going to continuously decrease our Z value the further we go backwards. And the Y, which is the second value, like how high we are in the workspace right now. So if I just fly up, then you can see that our Y value is constantly increasing. And if I just drop back down, then it goes all the way back down to where we are inside of the world. So these are the 3 positional values that represents a Vector3 if you were to compare this to Roblox. But it's essentially the same idea. So this was just something I wanted to show you before we start implementing this stuff, just so that you can get a better understanding of what the heck a Vector3 value is. It's pretty much a vector that comprises of 3 values called the X value, the Y value, and the Z value that can be used to change values of parts that are inside of our Roblox world. Not just with positions, but with sizes and rotation and all of that sorts of stuff. So that's what we're going to be doing in this episode. Now that we understand it, let me show you what a vector looks like inside of Roblox Studio. So on the top right of the screen, I don't know if you have this, but this essentially shows us our directional values with X, Y, and Z to tell us where inside of Roblox Studio our 3 axes are located. So if we go this way, then it's going to increase our X value. If we go backwards, it's going to decrease our X value. And if we turn around this way, then we increase our Z value by going this way. And of course, the Y value, it's basically determined by how high you are versus how low you are. So now let's translate that to a part when we insert it inside of Studio. So let's go up here to Model and hit Part. So with this part, we can come down here to C-frame, and we can see that there's a property called Position. Ignore this position that's inside of the origin category. We're mainly focused on the C-frame position. So this one basically shows us our X, Y, and Z coordinates, just like in Minecraft. So if we select this part, select Move, and move it in this direction, it increases our Z value. If we make it go back this way, it decreases our Z value. And if we make the part go this way, it decreases our X value. And if we make it go this way, then it increases our X value. And of course, the same thing for the Y value. Increase it goes up here, and then just goes back down here. So that's pretty self-explanatory. We can even change individual values of our X, Y, and Z position. So we can make this 5, for example. This just makes it 5. And then for Z, we can make it 10. It goes this way. So you get the basic idea. Our position consists of 3 values, X, Y, and Z, that's basically contained inside of one data type called a vector3. And now I'll show you what it looks like in a script. So what we're going to do is on the right side, let's click on the plus sign at part, and let's insert a script. And we're first going to make reference to our part, which is going to be local part equals script.parent. And then what we'll do is we're going to change the position of the part when we run this script inside of our game. So currently right now, our position is -12, 0.5, and -11. Let's change it to something different. Let's change the position when we run the script by saying part.position equals. And now you have to understand how to actually create this new vector value. And we will do that by using a new constructor. And the way it's going to look is something like this. We're going to say vector3 dot new, because we're constructing a new vector3 value full of 3 different numbers put inside of here. So we're going to say open and close parentheses. And now inside of here, we're first going to put in our new X value, which we're going to say 10, and then our new Y value, which we'll just say 3. And then our new Z value, which is going to be, let's say, 10 again. So effectively, this is going to replace the part's position, which is currently this value right here, -12, 0.5, and -11, to this new value, which is going to be 10, 3, and 10. So let's go to the game, hit test. We're going to hit run because we don't need to play the game in order to see this. And as you can see, the script ran and it automatically changed the position of this part when we ran this script to change its position to this new value right here. So to reiterate, a vector3 is a data type that holds 3 numbers, the X value, the Y value, and the Z value, to change the position of this part. But vector3s can be used for other things other than positions. So if we look more into this part, let's look at some properties that also have 3 values. So for instance, our size has an X, Y, and Z. Our orientation, also known as our rotational value, has an X, Y, and Z, so we can use vector3s for that. And then some other complicated stuff like assembly linear velocity and assembly angular velocity that also has X, Y, and Z values. So anything that has 3 values that are comprised of X, Y, and Z coordinates is deemed a vector3 data type. Now let's do some vector operations. And what I mean is adding, subtracting, multiplying, and dividing, like all of those basic operations with multiple vectors. And I'll show you a really easy example for this one. So if we select our part, I don't know if you noticed, and we have it selected to our move tool, then it automatically shows our X, Y, and Z axes to be able to change the location of the part. But now what we're going to do is basically take the position of this current part and add a new vector to it so that it'll just move in a certain direction rather than having a whole new location. And we're going to do that first by changing the position of this to something very easy to grasp. So let's just highlight this and make the position at the origin of 0, 0, 0. So we're going to select position, and we're going to put in a 0, 0, 0. And so that's going to be located at the very origin. Let's take our spawn location and just move it a little bit so we can see this part. And now our part is in the origin of the world. But let's also move the base plate down a little bit so that the part has room to be able to move freely without being clipped through any parts. So let's change the Y value of the base plate to -8.5. So now we should be able to see the part freely over here with no issues. Let's also move this spawn location a bit over here. Okay, now essentially what we want to do is take this part, have its current location, which is 0, 0, 0, and add a number that goes in the Z direction. Like, let's say 5. 5 in this direction. So first what we're going to do is go to our script, and let's delete this new vector3 value that we created. And how we're going to change this position is by obviously getting the part's position first. So we're going to say part.position plus vector3.new, and we want to just change the z value to wherever it currently is plus 5. So what we're going to do is first put in our x value, which is going to be 0, comma, our y, which is also going to be 0, and then finally our z value, which is going to be 5. So basically, we're going to take the parts position, which is just 0, 0, 0, and then add that to a new vector with 0, 0, 5. So in the end, this will end up resulting in a new vector3 position that is 0, 0, 5. So let's see what happens if we hit test and hit run. We should see that when the script fired, it moved the position of this part to what it was at the beginning, which was 0, 0, 0, and then to 0, 0, 5. And the reason it looks like this is because we have the part anchored, so it was impacted by gravity a little bit. Let me just anchor this part so that we can really see the new vector change. So if we select the part again, then as you can see, our position is now 0, 0, 5 because its original position before the script ran was 0, 0, 0. And then we added a 5 to the z value to make it 0, 0, 5. I hope this basic example made sense a little bit, because when we use vectors, we are going to be using computations to get a new result from different vector values, like adding vectors, for instance. And there's also another way of writing this too. Instead of just reiterating part.position equals part.position plus vector3.new, what we could do instead is delete this first part, and we can just put in a plus equals. This basically means the same thing as the one we just had before, where we basically take the current part's position and add a new vector to that position, and we should just get the same exact result. It really comes down to preference which one you like to do more. I'm just letting you know this is also another way of just taking the current part's position and adding a new vector to it. We can even do this with subtraction, and there's two ways of doing subtraction. So the first way is just taking part.position and then subtract equals vector3.new 0, 0, 5. So just to make this easier, let's change the syntax to part.position minus instead of what we had before. So the part's position is going to be whatever the position it currently is, and then subtract that by our new vector here. Now you have to be careful that this is supposed to be a 5 and not a -5, because we are subtracting this vector. So if we have a 5 here, this essentially means take the z value and subtract it by 5. So if we go into the game, we should see that the z value will go in the other direction, so it goes back here. So our z value is now -5 and not 5. There's another way of writing this. We can actually do part.position plus vector3.new -5, and this should basically give us the same result as subtracting a vector3 of 5. So as you can see, it basically did the exact same thing as we did with subtraction, except we kind of just flipped the signs around, because as you know how math works, if you flip signs, you can basically get the same result in this way if you prefer to do it. So I just wanted to let you know that there's two ways of making this calculation. And then of course you have multiplication and subtraction, which I hope you know how those two operations work. So the way multiplication works is we're going to replace this plus sign with an asterisk. So this represents multiplication. And we're going to multiply the current part's position to whatever new value we have here for vector3. Let's get rid of this z value by putting in a 0, and let's change the x value to 2. So what it's going to do is it's going to take the x value of this part, which is 0, and it's going to multiply it by 2. Now what should happen is that it's still going to be in the same place as it usually is, because 0 times 2 is 0. So let's actually change this position to 1 so that we can effectively see the multiplication that we do with this part. So it's a very small difference, but as you can see, our x value changed to 2 because 1 times 2 is 2. So we effectively made that calculation. And you can pretty much do the same thing with division. It's basically a forward slash to represent division. And you basically get the idea. I hope so far this is making sense to you because there is a bunch of math required when it comes to vector3 values. In due time, the more you practice, the more you'll definitely get better at it, so I believe in you. But anyways, we dealt with changing the position of this part, but there are other values we can change that uses vector3 values like size and rotation, or orientation in this case. So let's change those values. And so the way we change the size of a part inside of Studio is by going to Model and going to our Scale tool. And it's basically the same way with moving, except we can scale this part in whatever axes we want to scale the part to, whether that be the X value, the Y value, or the Z value. We can pretty much do the same thing. And this also takes in a vector3 value. So if we want to change this through a script, we essentially do it the same way we do with the position. So let's go to our script and let's change the part's size. So we're going to say part.size equals vector3.new, and we can put in some value like 4, 4, and 4. So it's going to change the size of this part to 4 when we test the game. So if we test it, then we should see that the part's size has been successfully changed to be 4 by 4 by 4. And we can even do the same thing with rotation as well. What we can do here is drop a line and say part.orientation equals vector3.new, and we can say 25, 0, 25. Let's see what that results in when we hit run. So as you can see, the orientation or the rotation of the part has changed accordingly to what we set it to do inside of our script. So it's basically the equivalence of our rotation tool. So the red is our X value, the blue is our Z value, and the green is our Y value. So it's a bit more confusing and less intuitive for X, Y, and Z values for rotation. So you're gonna have to be familiar with how rotational axes in orientation works with parts or models inside of the game. Another thing we can do is multiply and divide a vector with just a number. So in this case, what we can do is we can take the position of our part and just multiply that vector value by a number to then change every value that's in the vector3 value. And I'll explain to you what I'm talking about. But first, let's change the base position of our part. So we're going to go down here and let's change this position to 1, 0, and 1. And let's go to our script. So let's delete these two lines of code right here. And the first thing we're going to do is say part.position equals part.position, and we're going to multiply this by a number. So we'll say times 5. You can take a guess what's going to happen here, but essentially it's going to take every value that's in this vector3, which is 1, 0, and 1, and multiply all the numbers by 5. So our X value is 1, so 1 times 5 is 5, 0 times 5 is 0, and then 1 times 5 is 5. From that, we're going to get a result of 505 when we run the game, like so. So if we select this part, we can see that the new position is 505 because we took the original position of the part, which was 0, 1, 0, and then we multiplied all those values by 5. And so that's how we got the result of this position. We can even do the same thing with division. 1 divided by 5 is going to give us a pretty small number, so it's going to have a very small difference. But let's see this very small difference in play. So our part should have a position of 0.2 because 1 divided by 5 is 1/5, and in decimal, that's 0.2. So I hope that part made sense to you. We're going to create a practical use case of vector3 values by creating a teleport script whenever the player joins the game. Let me show you how this is going to look. So first thing we're going to do is create a new part. So let's go to Model, Part, and let's rename this part to Teleport Part. Let's even change the color of this to to blue, and let's move this over here. Now what we're gonna do is create a script inside of server script service, like so. And then what we're gonna do is create a player added event. So game.players.player added connect function, open parentheses, close parentheses, enter. The parameter here is going to be player. One thing we have to do is know how we can actually teleport our character to another position inside of the game. So I'm going to show you how we're going to do that right now. If we open up workspace and go to our character and open this up, we can see that there's a part here called HumanoidRootPart. It's kind of hard to see the humanoid root part, but essentially it's like an invisible box that's surrounding our torso area, much like our upper torso. So we can actually see our upper torso here. But our humanoid root part is like this invisible part that basically connects all of the attachments to our character together into one. And so we're going to be changing the position of this humanoid root part to the position of our teleport part in order to move our character from where we currently are to that part over there. So that's what we're going to be doing. So now that we understand that, let's locate the humanoid root part by first making reference to the humanoid root part. So we're going to say local humanoid root part equals player.character. And we're going to wait until the player's character completely loads into the game. So we're first going to say, colon, wait for child. So we're going to have the script wait until a humanoid root part exists inside of the character. So in quotations, we're going to say humanoid root part. And then down here, we're going to say humanoid root part dot position. So we're going to modify the position of the current humanoid root part equal to game.workspace dot teleport part dot position. So in these two lines of code, we're basically getting the humanoid root part from the player's character, and then we're going to change that position to the position of this teleport part over here after the player has joined the game. So if we hit play, okay, so there's a little error here. There isn't enough time for the script to wait until the player joins into the game. So we can either do this in two ways. One is by adding a task.wait function, or we can add in another event that calls the character every time their character loads into the game or resets. So for the sake of simplicity, let's just add a task.wait to this event. So we're going to say task.wait, and then we're going to wait 5 seconds before the script runs. So let's go into the game and hit play. And after we wait about 5 seconds, it's going to locate the character's humanoid root part, and then we should be able to teleport just fine. So as you can see, our character did indeed teleport to the part's position, but then we kind of slid off a little bit, because if we're teleporting our player to the direct position of this part, it's going to literally be inside of this part. So what we can do, we can add a Y value of 5 so that the player spawns right on top of the part, not in the part. So we're going to go over here, and let me just zoom out a little bit, and we're going to add in a new vector by saying plus vector3.new 0, 5, 0. So it's going to take the teleport part's position and add 5 to the height, or the Y value, so that the player spawns right on top of it, not inside of the part. So let's go into the game and see our change. After about 5 seconds, it should spawn our character on top of the part, not in the part. So there you go. Our teleport script should be working just fine. I hope this introduction to Vector3s served you well. I'm not going to go over every single thing that Vector3s have to offer, because this just serves as an introduction to get your foot in the door to be able to understand Vector3s for your future Roblox projects. Because Vector3s, it's a complicated data type, and it'll only get more complicated from here. So I highly encourage you to read the documentations for Vector3s. Maybe look up more tutorial guides from other YouTubers who've talked about Vector3s as well, so that you can really understand how you can use these Vector3 data types in your Roblox games. Again, I hope this introduction to Vector3 served you well. Continue to improve your Roblox developer skills, because sitting down and struggling through things that are tough for you will make you a more competent Roblox developer in the long run. And I believe you got this. So that's going to be it for this episode. Join my Discord server. The link is in the description. And I will see you in the next episode. Take care.